Hi everyone, you are welcome to DML Physics Concepts. Thank you for watching our videos. Kindly subscribe to this YouTube channel and like this video, make a comment, and at the same time, please don't forget to share this video so that every students that you know they are science students can also benefit from this video. Thank you for doing that. Now today we will be concluding on current electricity, and today we'll be looking at resistivity and conductivity. Now, the word resistivity is actually coined from the word resistance. We remove it from the word, is from the word resistance. And conductivity is coined from the word conduction. Now, what is resistivity? So let me go with the resistance first. We've defined resistance as the opposition to the flow of current in a circuit. So which means in a circuit, there are materials we call resistors. And these material, they oppose the flow of current in the circuit. So what is now resistivity? Resistivity is the ability that a material has to oppose the flow of current in a circuit. So in other words, we can say resistivity of a material is defined as the resistance per unit length per unit cross-sectional area of the material. So we can define resistivity in short and say resistivity is just the ability of a material to oppose the flow of current in a circuit. Alright, how do we deduce the formula for resistivity? So let's first look at some things. And what we'll be looking at is the factors that affect electrical resistance. So today, I'll be giving us 4 factors affecting electrical resistance. As we have it on the board, those factors are: number 1, length of the conductor. The length of the conductor affects the electrical resistance of a conductor. Now, what we are talking about is that the more the length, the higher the resistance. The more the length, the higher the resistance. So the relationship is simple as saying that the resistance of a circuit or resistance of a conductor of a material is proportional to the length of the conductor. So we can say R is proportional to length. So which means the more the length, the more the resistance in the circuit. And the smaller the length, the smaller the resistance in the circuit. So let's look at number 2. Number 2, temperature. How does temperature affect electrical resistance? Now we know that if current is transmitted through a long distance, there will be energy loss. When current is transmitted or through a long distance, through a conductor over a long distance, there will be energy loss in form of heat energy loss. And heat has a relationship with temperature. So we can now say also that when the resistance increases, the temperature of the whole system increases as well. So when the resistance increases, the temperature of the whole system also increases as well. So we can also then say that relationship between the resistance, electrical resistance and temperature is such that resistance is proportional to temperature. Now let's look at the third one. We have the cross-sectional area of the conductor. The cross-sectional area of the conductor is talking about the thickness of the conductor. So the thickness of the conductor has something similar or related to when we're talking about the length of the conductor. So in other words, now if we want to look at the relationship between the cross-sectional area now, then we say the resistivity is inversely proportional to the cross-sectional area. So resistivity is inversely proportional to the cross-sectional area of a conductor. Then finally we're talking about the nature of the resistor or the nature of the resistor material. So resistivity, or let me say the resistance of a circuit, is also proportional to the nature of the resistor. So the nature of the resistor is, otherwise we can call it resistivity of the material. So we'll say that the resistance of a circuit is also proportional to the resistivity. So having that we have all these parameters, we should know that the resistivity of a material is measured in ohm meters. The resistivity is measured in ohm meter. Resistivity of a material is measured in ohm meter. However, when we get to conductivity, we'll tell more of how conductivity is measured. Now let's look at this. We can combine this formula together, or this relationship together, because you can say it's a joint variation. This is first variation, second variation, third, fourth variations. So we can decide to join 1, 3, and 4 together. So if we join 1, 3, and 4 together, we are going to arrive at a formula which is going to be R, which is equal to L. This is L is directly, this is also directly proportional to the resistance. So we have L proportional, resistivity proportional. So R equals to, we have the L rho, then because this one is inverse, L rho over area. So the resistance of a circuit is given as L rho over area. Sometimes some students can say resistance is equal to rho L over area. Anyhow you put it, we are still having the same formula. So resistivity is given as rho L over area. So we will be able to achieve a formula to find the resistance in a cycle. So this formula will be used as we proceed in this class. So let's look at conductivity. So if resistivity from the word resistance is talking about opposing the flow of current in a circuit, then conduction is talking about allowing flow of current in a circuit. So in other words, we can just say resistivity and conductivity, they are inverse of each other. They are opposite of each other. So in order to generate a formula for that, we can now say, okay, if resistance is RL over area, remember this is the resistivity. So let's make resistivity the subject of the formula before we can now say what's going to be the formula for conductivity. So if I make resistivity the subject of the formula and I cross multiply, then I'm going to arrive at this formula where resistivity is going to be AR over L. So if resistivity is AR over L, now what is going to be conductivity? And I said conductivity is the reciprocal of resistivity. So therefore we now say conductivity is going to be the inverse. So it's going to be L over AR. So let's write that. So the conductivity is L over AR. So this is rho for the symbol. This is a rho symbol. And why this one is the sigma. So the sigma is L over AR. Then we can rewrite the conductivity formula, because if conductivity is inverse, then we can rewrite and say conductivity is 1 over rho. So if rho is AR over L and conductivity is L over AR, then we can now say the sigma, which is the conductivity, could be given as 1 over rho. Then it is also very important to know that if resistivity is measured in ohm meter, then conductivity will be measured in inverse of ohm meter, because it's an inverse of each other. So conductivity will be measured in ohm meter, the two of them inverse. So the inverse of ohm meter. All right, thank you for watching this video. So next thing now is cycle. So let's look at example 1. In example 1, calculate the resistivity of a wire of length 2 meter and cross-sectional area of 0.004 centimeter square if its resistance is 3 ohms. Now something you need to understand is we want to pick the parameters from here. So let's pick parameters first before we look at this. So let's leave this aside. Let's first pick parameters. Now we want to calculate the resistivity, so we are looking for rho. So that is unknown. Resistivity is what we are looking for. If the length L is 2 meter, then after that we're looking at they give us cross-sectional area. So cross-sectional area is 0.04 centimeter square. So if the area is 0.04 centimeter square and they give us resistance to be 3 ohms, so it's very straightforward. What's going to be our formula? Our formula is going to be resistivity equals to what? AR over L. So you remember that resistivity is AR over L. So we'll say the resistivity is going to be AR over L. So it's just straightforward like that. You just substitute. But before you substitute, remember I tell you in physics that after application of formula, we need to also understand unit conversion. So if the unit is not the SI unit, we don't use anyhow. So what we are going to do is that this one is rho we are looking for. So L is in meter, that's correct. Area is given in centimeter square, so that's why we have to look at this. So you have to understand this unit conversion. 1 millimeter is 1 over 1000 meter, or we can say 0.001 meter. But what is now going to be 1 millimeter square? 1 millimeter square is just 1 divided by 1000 in two places. So it's going to be 1 over 1 million, 1 0 0 0, then another 0 0 0. So if you are changing from millimeter to millimeter square, you just you divide by 1 over 1 million, and that's going to give us 0.0000 as we have here, 1 meter square. So also for centimeter, if 1 centimeter is 1 over 100 meter, then 1 centimeter square is going to be 1 over 100 in two places. So 1 0 0, then another 0 0. So that's why we have 10,000. So that's how we get our unit conversion. So let's now convert 0.004 centimeter square. So if I want to convert it to meter square, then just simply by saying 0.0004, we divide it by 10,000. So let's do that now. So for our conversion. So if we now divide, it's going to give us 0.004 centimeter square is going to be 0.04 by 10,000, and that's going to give us 4 times 10 raised to minus 7. When you place your calculator and I change the standard form, I'm going to have that in meter square now. So now that we have converted our area to meter square, so the next thing is we now substitute to this formula. So resistivity rho now equals to area. Our area is 4 times 10 raised to minus 7. Then multiply by our resistance. Resistance is 3. Then divide by 2. If I multiply this one by 3, it's going to give me 1.2 times 10 raised to power minus 6. 1.2 times 10 raised to power minus 6 and divided by 2. So if I divide my result by 2, so what am I going to have? I'm going to, let's look at the result when we divide by 2. So when we divide by 2, then we are going to have, our answer is 6 times 10 raised to power minus 7. And what's our unit? Our unit is ohm meter. So this is how we solve resistivity of a cycle. So if I say find conductivity in this case, so after we have gotten the result for resistivity, you just inverse it. Just say 1 divided by this O value will give us our conductivity. So thank you for watching this video. So I will just give you some of the examples that you can also practice with. I'll write them after this class. So all those examples, just practice with those examples, and if you have any question, you can ask in the comment section. Thank you for sharing this video, and God bless you. So that's the question. You can just practice the questions and make sure you use the appropriate formula and use the appropriate unit conversion. All right, so if you get the answer, I will drop the answer in the link. Just check the link, description link below. So when you check the description below, just verify your answer for number 1, number 2, number 3, and you can also drop your comment if you have any question. Thanks for watching this video, and God bless you. Bye.